Today's lesson is about the global atmospheric circulation. This is the pattern caused by the movement of air around our planet. It sounds complicated, but it's based on a few simple ideas. The first thing is that the amount of solar radiation has an inverse relationship with latitude due to the curvature of the Earth. This sounds complicated, but it means that places with a low latitude, places near the equator in other words, have a high amount of solar energy. That means they are hotter. Places with a high latitude, places near the poles, have a low solar energy, which means that they are cooler. You can see the reason for this is that the energy is spread around the Earth, where the Earth curves away from the Sun. At the equator, the Sun is directly overhead, so that energy is focused on a small area, heating it up more. But at the poles, the energy is spread out around that curve, and so each square kilometre of land, for example, gets less solar energy and is cooler. Air pressure is one aspect of climate that is influenced by the amount of solar radiation. Air pressure is the weight of air pressing down on the Earth's surface. It's measured in millibars, which we record on a barometer. The average pressure at sea level on planet Earth is 1013.25 millibars. Low pressure is something that you've probably heard of. When air rises, there is less air pressing down. That means we have a low amount of press. When thinking about pressure, just think about the word press. It even says the word press in the word pressure. So warm air, which rises, gives us low pressure. If air is sinking downwards, that means there is more air pressing, which leads to high pressure. So cool sinking air gives us high pressure. Low and high pressure give us very different weathers. But if air rises away from the Earth when it's warm, what stops us from suffocating? The answer is that air moves from areas of high pressure, where air is sinking, to areas of low pressure. As the air rises at areas of low pressure, it creates a vacuum, sucking in air to fill the gap. We call that moving air wind. As rising air in areas of low pressure cools, it causes condensation and clouds form. This gives us precipitation. The rising air cools as it moves further away from Earth because the Earth is the source of heat. The air isn't heated by the sun directly. The sun's light passes through the atmosphere, striking the Earth where it's converted to heat energy, and that heats the air, which is why the air rises. So as the air moves further away from the Earth, it cools down, a little bit like you moving further away from a radiator. Conversely, where air is sinking, cold air in the higher atmosphere sinks. It warms as it gets closer towards the Earth. This evaporates moisture, a little like using a hairdryer to evaporate the moisture on a mirror in your bathroom. That means that there are no clouds and no precipitation, which gives an area very dry weather. And this whole cycle of air creates a convection current, which you've probably studied in science. So there are three simple principles to all of this. Warm air rises and cools, cold air sinks and warms up, and air moves from high pressure to low pressure. If you want to be really smart, then you need to know that the air doesn't move in a straight line between low and high pressure. What happens is that the rotation of the Earth means that the winds spiral. They spiral in a clockwise direction away from high pressure and in towards low pressure areas in an anti-clockwise direction. So now you know what causes our climate, and all of this is caused by the energy from the sun. But it's a little more complicated than that. There's a series of these convection currents. We have the Hadley cell, the Ferrel cell, and the polar cell. You can see them on the diagram in this slide. Let's concentrate on the Hadley cell for a moment. This is a convection current that influences the climate of the tropics. Air rises at the equator, cooling and condensing and causing clouds. It's thrown outwards by the spinning of the Earth, and this cool air now sinks and descends around about the tropics, perhaps 30 degrees north or south of the equator. That air is then sucked back into the equator, and the whole cycle continues. Here's that in a little more detail. The warm air at the equator rises and cools, causing large amounts of cloud and large amounts of rainfall. The rotation of the Earth throws that air outwards, and now it's cool and it's dry, and it begins to sink around about 30 degrees. That sinking air with very little moisture in it causes an area with no clouds, no rainfall, the deserts. That air is then sucked back inwards towards the equator, completing the convection current. This creates bands of climate roughly following the lines of latitude, which leads to distinct ecosystems in bands too. We'll do more ecosystems later in the GCSE course. At the equator, rising cooling air creates heavy rain. This area is warm due to high levels of solar radiation, which makes it perfect for plant growth. This creates the tropical rainforests. At the tropics, sinking air, which is dry now, creates deserts. This air is dry because as the rain fell over the rainforests, the air dried out, but also because as the air sinks, the moisture evaporates as it gets closer to the warm earth, giving an area with no clouds and therefore no rain. And in between these two ecosystems, we get an ecosystem that's in between two, the savanna grasslands. This area has a wet season and a dry season as the earth tilts towards and away from the sun. So, to summarise, rising air cools and condenses, forming clouds which give us precipitation. Sinking air warms, evaporating moisture, so we get no clouds and no precipitation. That gives us different ecosystems, with the rainforests being an area where air is rising, creating lots of rain, and the deserts being an area where air is sinking. Let's have a look at what that means for the continent of Africa. At the equator, we get the Congo rainforests. To the north, we get the Sahara Desert, and to the south, we get the Kalahari and Namib deserts. In between, we have those dry savanna grasslands with more woodland near to the rainforests, and then those trees dying out gradually as we get towards the deserts. So, a bit of a recap. We have tropical rainforests at the equator. We have savanna grasslands just north of that, around about 15 degrees. And then, as we go further north again, we get the hot deserts. Unfortunately, the UK is just south of where rising air between the ferrule and the polar cells creates a band of rain, which can wobble down towards us, especially in the winter. The observant amongst you will have noticed that the pattern of climate and ecosystems doesn't form perfect bands around the Earth. There are breaks in those bands, or they wobble north and south. The question is, why? One answer is the location of the oceans and the continents. If the air is coming off an ocean, then it's going to bring plenty moisture, and that will give a larger amount of rainfall. If it's coming off the continent, then the air will be drier, and there certainly won't be enough moisture for tropical rainforests to form, for example. The distance from the sea is also an influence. Even though the air may be coming off the sea, the further inland you get, the less and less moisture there will be left in that air, and so the drier the climate will be. The wind direction is also an influence, again relating to the oceans and the continents, but also if that air is coming from the north or from the south, then it will give slight variations. And the altitude is important. For example, Mount Kilimanjaro, Mount Kenya, in Africa break up that band of rainforest. So that's the end of the presentation. It's time to see what you've understood. Have a go at these questions. Write your answers in detail, in full sentences. Use images from the presentation if you need to. I've put the PowerPoint on Show My Homework so that you can copy and paste from there, or you can use the internet. You can always replay the presentation if you get stuck.